Okay, so it says the graph of the boundary equations for a system of inequalities is shown with the system to the right. Locate the solution region and identify it by finding the corners. So they've given us a system of linear inequalities. It's a system. We've got more than one equation. In this case, we've got two relationships for x and y, and they're asking us to find the solution region. Now, this is a graph that we could have produced easily enough on our own, whether we did it in the calculator or by hand, but in this case, this problem has already taken the time to draw the lines for us to really emphasize this solution region and the corners. Because moving forward, the word problems and we're doing optimization, whether it's finding a maximum or a minimum, will all come hand in hand with these solution regions and the corners in particular. So let's start by figuring out which of these lines is which. I'll just mark them with some colors. So if you notice, by the way, when you move forward with these problems, it's going to be, in my opinion, really easy to focus on intercepts if you can. Like if you notice the y-intercept for the first equation here, which I'll mark in red. Actually, you know what? Let me do that in blue. Because if I'm right, that's actually the blue one. So if we do like an xy table, right? If x is 0, y is 13. If y is 0, x is 13. So I've got this 2 points already in mind. If you notice that is the blue line there, 13, 13, 0, 0, 13. But if I were to draw this graph myself, I've already got a pretty decent idea of what that part looks like. So you can do the same thing for the other line. Notice I'm focusing on the line as if it were an equal sign for now. We'll take care of this less than part in a second. So if I make x 0, y is 21. And if I make y 0, x is going to have to be 7. So those are relatively easy points to get. When you plug in a 0, you just imagine that term isn't there. So let's see, 0, 21 should be there, and then 7, 0. You notice looks good. So we've established like which line is which. I'll mark this one in red, this one in blue. And of course, if I was to continue with my little makeshift graph down here, up here I can call that 21, and maybe since this was 13, we'll call that 7. And I've already got a pretty general idea what this graph looks like, right? Now, of course, this is a better version, so we'll stick with that. Okay, now the thing is, we're not done. First of all, because these are less than or equal to, sometimes the lines themselves are actually going to be dotted rather than solid. Now, in most cases, they will be solid, but in this case, they're solid. But if you were to just get a less than, for instance, instead of this solid blue line here, you would have a dotted line. And that would go with the just simple less than or greater than. But if it has the or equal to, then you're using a solid line. So no surprisingly, these are both graphed with solid lines. And the other piece we have to consider is the solution region. And that all has to do with these inequalities here. And there's a couple ways you can go about this. I don't know why I got rid of that. That was supposed to be there. But I think the easiest approach is to just do what's called a test point. All right? I'm going to test a point. Now, you can use any point you want within a certain parameter. Whatever point you use just cannot be on either of the lines, right? Cannot be any point that actually lies on the line. But the easiest point conventionally is to just use 0, 0 because it serves as a really easy point to evaluate, and it's very rarely on either of your lines. So I'm going to test 0, 0, and if you notice 0, 0 is right here, located in green. When you plug 0, 0 into the first equation, right, 0 plus 0, is that less than or equal to 13? Well, it is. So in this case, when I plugged in 0, 0, I got a true statement. So that means relative to the blue line, because if you notice that's the blue equation, points on this side of the line are true. Notice if you had plugged something over here, like let's just say for argument's sake, I picked like 2020. Right here's 2020. If you plug 2020 in, you're going to get 20 plus 20 is 40, is less than or equal to 13. Well, 40 is not less than or equal to 13. So points on this side of that blue line are not true. Right? So whether it's true or not true, it still tells us what we need to know. On this side of the line where I plugged in 0, 0, I'm getting true statements. That means this is the side of the blue line that I care about. Right? Over here, since this was false, that would tell me this is the side I don't want. Right? Now, you typically aren't going to plug in something like 2020. 0, 0 is always a good, easy number to use. In this case, we plugged in 0, 0. It was true, so we shaded the side. But let's just say if you plugged in 0, 0 and you got something that wasn't true, like if it was greater than 13 there, like 0 plus 0 is greater than 13. Well, that's not true. So you have to shade the opposite side. So if your test point is true, you shade that side. If your test point is not true, you would shade the opposite side. All right. Let's test the red line. Now notice if you were to plug in 0, 0 into the red line, again, you get another true statement, right? Like I'll just use, I'll use a different color for a second, just because I want to show you where it overlaps. So we're going to test 0, 0 again in here, and when we plug in 0, 0, we get another true statement. So because I plugged in 0, 0 and got a true, I'm looking to shade the side that has 0, 0 again. 0, 0 gave us a true statement, so I want to shade the side that has 0, 0. So here's the red line, and I want to shade towards 0, 0. Right. Notice I'm only staying to the left of the red line. Now the other thing that's, now this will always show up implicit in the word problems, meaning when you set this up yourself, they won't necessarily outright tell you this piece. You'll have to consider what the variables mean. Usually the variables will mean like number of goods produced, something like that, something that needs to be positive. But in this case, in the system, it's just there. It says, hey, x needs to be positive or at least non-negative. It needs to be greater than 0 or equal to 0, and so does y. That's another way of just saying we got to be in the first quadrant, right? This is the only quadrant where x is positive and y is positive. So that means we're not going to consider anything that's to the left of the y-axis or below the x-axis. Only positive values of x and y. So if we consider the region that satisfies everything, right? We saw it has to be to the left of the red line, but also beneath the blue line. So that means we got to get rid of this piece, because while that is to the left of the red, it is not below the blue. We'll also have to get rid of this piece over here, because while this is under the blue line, it is not to the left of the red line. See? So, and then, of course, we don't care about anything over here or down here because we got to be in the first quadrant. So this region here in purple is what we would consider the solution region. So I'll just fill that in now. Just erase it real quick. This region here, I guess I'll do it in blue. We'll do purple. Here's my purple back. We'll do this in purple, and this is the solution region. Okay, now on the homework, it'll be a little easier. You just dump the paint bucket in there. I'm just going to do my best to kind of fill that in. Okay, now we got to get the corner points. That's the other piece. The corner points are the points of intersection between any of these lines and the region itself, on the edge of a region. So if you notice, I'm going to get rid of this purple again, since we can hopefully visualize where the region is by now. We have a corner point right here. We had a corner point down here, and we had this corner point here, and then we also had this corner point. Right, so 4 corner points, right? They all lie at the corners of that region that was considered our solution region. So how do we find them? Well, we got to pay attention to what's intersecting there, right? Like if I was to start with, we'll call this point corner, just to make room and get rid of this now. Get rid of some of this stuff. I will not get rid of that. Okay. Let's start with this. I'll call this corner point 1 right here. Right. Well, what's intersecting there? Well, it's the blue line, which is x plus y, and because we care about the line itself, we'll just treat it as an equal sign for now. That's intersecting with the fact that x is 0, right? This vertical line is x equals 0. Anywhere on that line, x is 0 here. So look, if you make x 0, well, what happens? We figure out that that must be the point 0, 13, and it always happens to be one of the points we use. Another reason why I like doing the intercepts when we actually do the graph by hand, because it always ends up coming back as one of the corner points. Anyway, so there's 0, 13. Now let's do another corner point. This one's pretty easy to get. Let's call this 2. Right? So corner point 2, of course, is just 0, 0. That's where x is 0, y is 0. That's the intersection of these two. Corner 3, I'll call that one right here. Right? Well, corner 3, notice, is the intersection. I'm sorry, that is not corner 3. This is corner 3. Purple. Right. That's the intersection of the red line, which is 3x plus y. Remember, we'll just use equal sign for the line itself. The intersection of the red line and the horizontal line, y equals 0, right? Y is 0 anywhere on this x-axis. So if we make y 0 here, we'll make y 0. Notice x has to be 7. And again, look, That's one of the points we came up with when we graphed it by hand. So 7, 0 is the third corner point. Now the last corner point is the intersection of the red and blue lines themselves. So I'm just going to get rid of this real quick. We'll leave those corners over there. And the way to get the intersection point itself is you have to solve the system of equations for the intersection. So like that's the intersection of the blue line and the red line. Right? So we'll just solve this system. Now you can do this in the calculator using the matrices. Or if you notice, if you were to just multiply the top by a negative, I'll just visualize subtracting them, right? Multiply the top by a negative, add them together. 3 minus x is 2x. Y minus y is nothing. 21 minus 13 is 8. And we get x has to be 4. And hey, since x plus y is 13, if x is 4, y has to be 9. So I know it looks like it's pretty easy to read from the graph here. You probably could say, hey, that's 4 and that's 9. But it's nice to be certain, and that's how you would figure that out. You would just solve that system one way or another, whether, again, using the matrix options in the calculator, or in this case, we just use the elimination method. But in either case, we figured out that that fourth corner, this corner right up here, which I can just call 4, was the point 4, 9. So the solution to this whole problem here was you needed to dump the paint bucket on this region here. That was called the solution region. And its 4 corners, and let me get these labeled correctly again. We've got 0, 13. We've got, there's 0, 0. Here was our point 7, 0. And then there's that point 4, 9. Okay. Hopefully that helps. And if you have any other questions, let me know. Thank you. Bye.